Hi guys, now I'm going to talk about integration testing. In the last video you saw about the unit testing, and now integration testing. I've already told you what is integration testing. It's nothing but after you finish your unit wise testing, you go for integration testing. The main concept of the integration testing is to uncover errors while you are integrating. That's what they've told. Uncover errors associated with interfaces. When you're going to separately check your modules, and then if you're going to uncover the errors in those, that's fine. But while you're going to integrate all those units together, a lot of errors actually will overcome. So you need to uncover all those errors. So testing done in that phase is nothing but your integration testing. So, and the main objective of integration testing is to take all the unit testing done modules, and then you're going to make into one whole system. Okay, and there are two approaches here: non-incremental integration testing and incremental integration testing. So what is non-incremental testing? So this is actually called as Big Bang approach. So what is Big Bang approach? Actually the entire, I can say like this, we may not even go for unit testing. It actually, they just take the modules and then they interface it, that is they integrate it, and then on the whole system is being checked. So think of, if you are going to, not going to check a unit wise, if you're going to build it, and then directly if you're going to build the whole units, a small units into the whole system, and if you're going to check it, think of the unit based errors and then the integration errors, that is errors during interfaces, all those stuffs. It will become a very Big Bang approach. It is a very tedious approach for you. You will get a chaos results, confused results. So it seems to be getting unrelated errors. You cannot encounter those errors. So you will feel like these errors are coming from unit wise, or it is like errors are thrown during the interfaces. So it's really very difficult for the people to actually overcome those corrections, those errors. So they are saying like the testing approaches will be like endless loop. It will take a lot of time if it's going to be directly coming into the integration testing, and that kind of testing is called non-incremental testing, and it is also commonly called as Big Bang approach. And then the next thing you're going to see is your incremental testing. There are three kinds of incremental testing. One is top down, the other one is bottom up, and the third one is sandwich. Actually, each program is constructed and tested in small increments. So by doing this incremental wise, so errors are easy to isolate and correct. Okay, so the interfaces are more likely to test it completely. So I can say it's like a systematic approach. So what is top down? I can say everybody knows what is actually from in English literal meaning. You can select top down, from top to down. So from top program, from the top module to the end. That is, maybe if you take your family, your root where your top will be your father, and the lowest will be the children in our family. So top is a father. So the hierarchy comes from father to the children, father, mother, and then their son, their daughter-in-law, and then their grandchildren, likewise from top to bottom. Okay, so modules are integrated by moving downwards through the control algorithm. That is, it's coming downwards from top to the down, so it's coming downwards. That is, it's beginning with the main module. Okay, and then the control program is tested first. The root one, I can say like the father, for example, he is actually tested first, and then modules are integrated one at a time. So father is actually tested, that there is main program is actually tested, then the sub module will be tested and then integrated with the main one, and the third sub module will be tested and then integrated with already two modules integrated already, right? So it will be integrated with those two modules. So likewise it happens. That is called top down integration testing. So here you have two things, that is depth first and breadth first. So we'll see what is depth first and breadth first, okay, in the forthcoming slides. Okay, so I can also say like your depth first is nothing but your top down, and your breadth first is also called as bottom up. Okay, so the top down integration, so the advantage of main is like no test drivers needed, and then you're going to come from the top. You're not suddenly going to come and check with the down thing. Okay, so the thing is like no test drivers are needed, because the very beginning testing itself we are going to start with the main program. So if a main program is missing only, you are going to substitute that with a driver, but here you are going to check with the main program itself. So here you are in need of stub only, so your driver is actually not needed for your top down integration. That's what they have told, like no test drivers needed. And then interface errors are discovered early, since you're starting from the main program. So interfaces errors you can discover in the early itself, okay. And the model features a debugging. And the main disadvantage is like, as I told you, like if you're going to check with the very main module, and then I've told what is stubs and drivers in my earlier video itself, or if you have any doubts you can check into the earlier video, and then you can see like in unit testing video I've told, okay. So the main disadvantage is sub needs to be created and substitute for model. Since you are going to check for the main module, and the main module needs some input from the sub-level modules, and if the sub-level module is not yet created fully, then what you'll do, so instead of sub-level module, you create another temporary module that is called stub. Okay, so with that you check. So the disadvantage is like mostly you need more stubs in order to check your main program in case if your sub-level modules are not created properly. Okay, this is the main disadvantages here. And then bottom up. So bottom up is like you start from bottom to the higher level. So in the bottom level, see here, this is your root, and then obviously when you're going to have a few sub-level programs, when you're going to have a hierarchy, it will not have so much of branch. See here, it has only one module for each branch. Here it has only one module, and for this branch you have only one module. For here you have one module. Whereas if you're going to have a branch of like from B, if it is going to hierarchy, is going to C, and then C will have DE. Usually in integration testing, especially in your incremental testing, what they do actually is you have another concept called sandwich. So in sandwich, what they say is like, this is your main target. This is your main target, and this will be considered a top level, and this will be considered as a lower level. Got it? So here in bottom up, all the modules in the lower levels are grouped together, integrated together, and they are processed. Testing will be done, and then they move to the other upper level hierarchy. Okay, so mostly, not mostly, like the concept of bottom up integration is like the lower level modules. The lower level have n numbers of modules. All the lower level modules are grouped together, and then it will be tested before going to the next upper level hierarchy. So that is your bottom up integration. So the advantage here is like this approach verifies low level data processing early in the testing process. Since it's a bottom up, only the lower levels are going to processed. And then the main disadvantage is like, as we saw in top up, the need of stub is actually very essential. So they consider that as a disadvantages. So when you are going to come to the bottom up, it will be vice versa. You need a driver modules to be built, because if you want to check the lower level modules, and then if if the lower level module needs some inputs from the higher level modules, and if the high level modules is actually not built up completely, then what you'll do, obviously you have to constitute or compromise your high level module with the temporary module that is called a driver. So you need a lot of drivers here. Okay. Okay. So what is sandwich integration? So it's got nothing but a combination of both top down and bottom up. So and then the main, I told you earlier, so the main thing in sandwich testing is actually viewed as 3 layers: the main target layer, and a layer above the target layer, and the layer below the target layer. I told you, this will be the main target layer, layer below, and then layer above. So this is your sandwich testing. So sandwich testing is mainly focused on the main target. So this testing is actually selected on the basis of system characteristics and structures code. So this integration testing, if it's going to happen, this incremental integration testing, if it's going to happen in a very good manner, then you can say like there's no any need for Big Bang scenario. If it's not going to be a disciplined or systematic manner, then obviously I could say like it will be a Big Bang scenario. See here, sandwich, the both bottom up and the top down are actually used here. Okay, and then now we are going to coming to the regression testing. So what is regression testing? The main concept of regression testing is like, if you know what is the baseline, would have seen this earlier. So baseline is nothing but if there is if you are freezing at one point, you're going to freeze that I'm not going to do any changes in my software, but you're considering that freezing point as a baseline. But suddenly if your client is going to give you some additional changes in your software, so what you have to do, you have to to go through a lot of process in order to change. Okay, so after a baseline point of that freezing point, if your client is going to give you some changes, and if you are supposed to do it, the main thing is like before doing it, you'll do a lot of testing, and that is called regression testing, to ensure that changes do not introduce any unintended behavior or additional errors. So by doing the changes, client have given you some changes, right? By doing that changes, whether my product will give me any unintended behavior or additional errors, so you will test for that. So that is nothing but your regression testing. So regression testing re-executes a small subset of tests that have already been conducted. So they do it again by doing your changes in order to ensure that it's not giving. I can also give another name for this regression testing is refactoring. I hope you would have known this term, you would have studied in the earlier units. It's refactoring. And next is your smoke testing. It's very interesting actually. It actually deals with the part of hardware. So the main thing is like when you have developed a product, so many people use, even though people are computer science, many people in a final year they do a project with some hardware components. So the main thing is like suddenly if you are going to, you have developed everything is breadboard with all resistor, capacitor, all stuffs you would have done, and then suddenly if you're plugging it in the power and if you're going to switch it on, suddenly you'll get a smoke or a spark or something else, or it might burst. Okay, so something happens like that. So that is called your smoke testing. So when a product is built, you check in, that is you plug in with the power and check whether is there any spark, smoke or dramatic signs of fundamental failures. Okay, and then in smoke testing also, when there's any changes coming in, you do it, and then you actually test it. Okay, so frequently actually test it. So your smoke testing includes the following activities. The software is compiled and linked into a build. A series of breath tests is designed to expose errors that will keep the build from properly performing stage. That's what they're saying, like it will be frequently tested. Okay, so the build is integrated with other builds. So suppose if you are building other modules, and if it is also integrating, suppose if you are going to introduce a capacitor or resistor in your product, and then if you are going to integrate it, again you actually test it whether if there is any sign of sparks or even maybe burst. So it actually, smoke testing is frequently done. Got it? Okay guys, so I'm finishing with this. So we'll see the remaining topics in the later video. Thank you.